Hey guys, and welcome to the school station. Today's video is going to be about calculating work done. This is from the AQA GCSE Physics 91 paper from the unit Energy and Energy Resources. Today's video I'm going to be talking about how to calculate work done, what is work done itself and its formula. This is also related to energy. So let's just get right into the video. So first of all, we have to think about the difference between mass and weight. Now, you have realized that whenever you go to the doctors, you may ask for your weight. So what is my weight? And you may check it in a weighing scale. However, this is actually incorrect because weight is actually a force. What we're really asking for is our mass. Mass is a quantity of matter. It is measured in kilograms. So when we go to the doctors, we're actually meant to be asking what is our mass, because we're actually looking for our quantity of ourselves. We basically want to see how much quantity we have, and it is measured in kilograms. And weight, however, is actually a force. And this depends on two variables, mass and gravitational attraction. It is measured in newtons. So you're going to have to remember the difference, that whenever you're in an exam, don't write weight as kg just because you see in the doctors you are, let's say, 60 kg. You actually have to think about that you're actually asking for your mass in the doctors because that is measured in kilograms and weight is a force and it is measured in newtons. There is also a formula for weight, which is mass times gravitational attraction. And if you remember this, you will also be able to relate to this in the gravitational potential energy formula, which is mass times gravitational field strength times height. So if you do mass times gravitational field strength, it's weight. So another way of saying gravitational potential energy is weight times height. So just over there, you'll be able to see that weight is a force. It depends on two variables, mass and gravitational attraction, and is measured in newtons. So it's really important to keep this difference in mind so that you do not get confused in the exam about the units for mass and the units for weight. So now that we've actually clarified the difference between mass and weight, the next thing we can look at is the definition of work done. So you might have been confused when you first came into this video about what is work done exactly. The amount of work done is equal to the energy transferred and is equal to the product of the force and the distance the object is moved in the direction of the force. So what they're really trying to say in simple words is work done is equals to energy transferred. You literally just have to remember that. If you want to have it in your mind in simpler words, work done is equals to energy transferred. The reason why is because you might have the same question but in two different forms. You might have one question where they give you the mass, they give you the speed, and then they're asking you for what is the kinetic energy transferred. This is the exact same question if another exam paper tells you, I'm giving you the mass, I'm giving you the speed, now find out the work done. It's going to be exactly the same thing, because what is the kinetic energy transferred and what is work done is exactly the same thing. So you might just see that instead of saying what is the kinetic energy transferred, they might just tell you what is the work done in this question, and you're going to have to find out using the formula and what you have. So this is basically the definition of work done. Work done is equals to energy transferred. And we're also going to be looking at about this more later on, about this part of the sentence, equal to the product of the force and the distance the object is moving in the direction of the force, because this is actually related to the formula for work done. So now we actually have to think about what is 1 joule equal to. 1 joule is the energy transferred when the force of 1 Newton moves an object a distance of 1 meter in the direction of the force. So let's just say, for example, I have an object over here. Let's just say a chair, okay? I have a chair over here, and I want to move it in the east direction at a distance of 1 meter. So I'm going to move this chair 1 meter, and I'm going to do it in the east direction. I'm using a force of 1 Newton. So what I'm doing, I'm taking a chair, I'm using a force of 1 Newton to move that object in a distance of 1 meter in the east direction. So if I'm using a force of 1 Newton and I want to move it a distance of 1 meter in the direction of the force, I am basically using 1 joule of energy. So that is what 1 joule is equal to. 1 joule is the energy transferred when the force of 1 Newton moves an object a distance of 1 meter in the direction of the force. If you have an object like a chair and you're using a force of 1 Newton to move that chair 1 meter in the east direction, or the south direction, or the west direction, or the north direction, whatever it is, and you're moving it, that's basically what 1 joule is equal to. You just used 1 joule of your energy. So now that you've clarified what is 1 joule equal to, what is work done, and also the difference between mass and weight, now we can actually look at finally the formula to calculate work done. So work done is equals to force times distance. This is that simple. You just have to know that work done is equals to force times distance moved. So force, this is basically exactly what I told you guys about 1 joule is equals to, because we talked about the force and the distance, and that is what this formula is about. You just have to say that work done is equals to force times distance moved, where force is measured in newtons and distance is measured in meters. And obviously, since work done is equals to energy transferred, it is measured in joules, and the distance must be in the line of action of the force, because as I said earlier, it has to be exactly the direction that you're pointing at. It can't go like in a wiggly line. It has to go exactly straight. Again, when we're moving an object of a distance of 1 meter, it has to be exactly in the east direction, or exactly in the west direction, or exactly in the south direction. So this is basically the formula, and you're going to have to memorize this for your exam. So work done is equals to force times distance. So that's basically what you have to remember for work done. So now that you've learned the formula, I want to actually go through 2 examples. The first example is a builder pushed a wheelbarrow a distance of 5.0 meters across flat ground with a force of 50 newtons. How much work was done by the builder? I want you guys to pause this video and try this question. Remember to use the formula, and also remember to actually realize what are the things you have in this question. Alright guys, I hope you guys have paused this video and actually tried this question out. So now I'm going to go on to the actual answer. So what I did was I used a formula. Work done is equals to force applied times distance moved. So it's basically force times distance. And in the question we saw that there is distance, which is 5.0 meters, and there is a force of 50 newtons. So 50 times 5.0 is 250 joules, and that's basically exactly what it was, 250 joules, and that is our work done. This is how simple questions can be. So I hope you guys have tried this question out, and I hope that you got the same answer as me, because now we're going to be going on to a more complex exam style question. Over here we actually have 2 parts of this question. There's part A and part B. Obviously try to do part A first and then go to part B. Over here is telling us the car is traveling at a constant speed of 20 meters per second when the driver applies the brakes. The car decelerates at a constant rate and stops. The mass of the car and driver is 1,600 kg. Calculate the kinetic energy of the car and driver before the brakes are applied. And then part B, which you would have done after doing part A, is how much work is done by the braking force to stop the car and the driver. Again, I want you guys to pause this video and try to also reflect on what we have learned in this lesson or in this video, and also remember about the formula. Alright guys, I hope you guys have tried out this question, because I know that this may seem very, very complex, but actually if you reflect on all the formulas you have learned in my previous videos and also what you have learned in this video, you'll be able to know how to solve this question. So here is the answer. So first of all, in part A, we actually have to think about what do we have. So they gave us the speed, they gave us the mass, and they're also telling us to calculate the kinetic energy. This is a really simple question, because they told us to calculate the kinetic energy already, so we don't have to think about which formula do we have to use, because they're already telling us to use a kinetic energy formula. So if you've looked at my previous videos, you will have known that kinetic energy is equals to a half times mass times velocity squared or speed squared. So I did 0.5 times 1,600, which was the mass of the car and driver, and then the speed, which was 20 meters per second, which was over here. And when we actually multiply this all together in the calculator, we got 320,000 joules. So if you got that, you can give a tick to your answer. However, part B was something that could have confused many people. This is relating to what we have learned in this lesson. How much work is done by the braking force to stop the car and the driver? Now, if you have not realized already, we've already shown you that the definition of work done is equals to energy transferred. So in part A, they were asking us to actually find the kinetic energy of the car and driver. And this is exactly the same question, but they just rephrased it in a different way. How much work is done by the braking force to stop the car and driver is exactly the same thing as saying calculate the kinetic energy of the car and driver before the brakes are applied, because the energy transferred and work done is equals to the same thing. So work done is equals to 320,000 joules again, because kinetic energy is equals to work done. Or kinetic energy turns into work done. So that's basically how you solve this question. It may have seemed very complex, but when you actually really look at what you have, what formulas you have to use, and what you have learned in this lesson, you'll be able to solve this question. Obviously, remember to try to look up many more questions as well and try to solve them. So that's our end to this lesson. Just as an overview of what we have learned today, we have learned the difference between mass and weight. So mass is actually a quantity of matter and it is measured in kilograms, while weight is actually a force and it's measured in newtons. And we've also learned what is work done. So work done is equals to energy transferred in simpler words. We also have learned the work done formula, which is work done is equals to force times distance moved. And number 4, we also learned to solve questions involving work done. For example, this complex one that we had over here. I really hope you have tried this out before looking at the answer. But yeah, I really hope you guys enjoy this video and I hope this helps you. Definitely give this video a thumbs up if this helped you, and subscribe to the school station for more free science and maths lessons. Bye guys!